Today we're going to look at number patterns and how we find a rule and how we might look at how patterns can be written down. So let's start with the most basic number pattern of all, the 2 times table. When we look at the 2 times table, we know that the first number in the times table is found by 1 times 2, which is 2. The second number in the 2 times table is 4, and the third number is 6, and so on. Each term has a constant difference. There's a common difference between each term, and this number here gives us the position. Okay, so if we call this, I don't know, n, the position in the sequence, let's call this a sequence, and t being the term number in that sequence, 2, 4, 6, we know that we can add 2 every single time. We should also know that we can find the number in the 2 times table for any position. We can say the 10th number in the 2 times table is 20 because we also know that there's a rule linking this position to the actual value, and we know that that's 2 times the position, or 2n. That's how we could write the rule. 2 times n, 2 times 10 is 20. So let's look at other sequences and see if we can work out what the rule is. Is there a rule going from one term to the next? Can we find a rule going from the position to the term number so that we can solve some problems? So let's have a look at another sequence. Let's look at a picture sequence. I'm going to draw some triangles. Okay, now obviously you don't know much about these triangles, but let's imagine they're made of matchsticks. Okay, so you've got matchsticks making up these triangles. So we can see that there are 3 matchsticks. The first triangle has 3 matchsticks. The second triangle has 6 matchsticks making it, and the third triangle will then have 9 matches making, as it goes 3 matchsticks along and so on. So 1, 2, 3, this is following the 3 times table. We can draw up a table of results. Whenever we have a pattern, we can draw up a table of results like this and start looking at the relationship between the triangle number and the number of matchsticks. And it's as simple as just setting up a table and then using those results to see if we can find a rule. So 1, 2, 3, we've got 3, 6, 9. Hopefully you've realized that this is the 3 times table, because the 3 times table is adding 3. It's got a common difference, a constant difference of +3 every single time. And we can also say that from the position to the term number, we multiply by 3. So we can say it's 3n. Okay, now let's go a little bit trickier now. Let me just create some space. All right, I've cleared some space. So I'm now going to draw a really basic sequence made up of some rectangles. Okay, so you can see there are 3 pictures in this. You have to assume they're all the same size as each other. This is drawing number 1, drawing number 2, drawing number 3. Let's have a look at how many sides there are, how many edges there are to each of these. So let's put the results in a table and try and find a rule. So let's say n being the diagram, the number. So 1, 2, 3 is what we have. Now we're going to count how many edges there are. So the first rectangle has 4 edges. This one here, we've got 1, 2, 3, 4, 5, 6, 7. This one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 3 pictures, we have a sequence that has established. Let's have a look if it's got a common difference. Well, from 4 to 7, we've got a difference of 3. We also have a common difference of 3 from 7 to 10. So we can say it's common because it's +3 every time. Now, we know of other sequences that added 3 every time. That was the 3 times table. But the 3 times table started, first position, the number was 3. This one is starting at 4. It's almost like it's a shift in the 3 times table, isn't it? Let's have a look if that might help us to find the rule. Common difference of 3. Okay, let's see. If we multiply by 3, let's see what happens. 1 times 3 is 3, plus 1 is 4. So the rule could be times by 3, add 1. Let's check it. 2 times 3 is 6, add 1 gives us 7. 3 times 3 is 9, add 1 gives us 10. We now can say to get any term number, so the 100th term, all we need to do is multiply by 3 and add 1. So let's do it. N is 100. 100 times 3 is 300 plus the 1, 301. There would be 301 edges if we were to draw the 100th pattern. All right, now sequences don't just come with a common difference between them. Sometimes they can be multiplied. Let's look at one in particular where the difference between the terms is not common, but there is something called a common ratio. Let's have a look. You might be familiar with the sequence 2, 4, 8, 16, 32. Okay, so we can see there's not a common difference at this point because the difference between 2 and 4 is plus 2. The difference between 4 and 8 is plus 4. The difference between 8 and 16 is plus 8. So it's not a common difference. But what we do know is that if we multiply this by 2, we can get 4. If we multiply 4 by 2, we get 8, and so on. So this is not a common difference, but there is what we call a common ratio. That means if we were to do 16 divided by 8, the ratio would come out as 2. 8 divided by 4, that ratio is the same because it comes out as 2. So we can see that each time, to get from one term to the next, we are multiplying by 2. And there are other sequences where there isn't a common ratio and there isn't a common difference, and we go to perhaps look at what we call second differences. These could be quadratic sequences. I'm going to show you an example of one that does not follow either of these two. Let's look at square numbers. 1, 4, 9, 16, and so on, 25. Okay, let's look at what happens. Let's look at the difference here. Okay, so no multiplying. 1 times 4 is 4, doesn't work. 4 times 4 is 16, it's not working. So let's look at adding. We add 3, then we add 5, then we add 7, then we add, now you can see here, we are adding 9. These are all the odd numbers. So if we then look at the second difference, we can see that they are now adding 2 from 7 to 9. Is add 2 every time. So we can see that the second difference of these is adding 2 every time. Now, this leads us to believe that there must be a rule linking the position 1, 2, 3, 4, 5 to the actual sequence, the numbers in the sequence. It just wouldn't be as simple as this because the first difference gave us what we call a linear relationship. When we look at the second difference, this is what we call a quadratic relation. Now in year 8 we don't learn quadratic, so I'm going to leave it there, but it's really useful to know how to find the next number in a sequence. Thank you very much.